Hello, in this series of videos I want to go through on how to set up and then solve an applied linear programming problem. So we want to first set up a linear programming problem given this scenario, and then in later videos we'll go through and solve it using Excel's solvers. So just to note, if you're looking at the textbook, Sullivan 11th edition, this is from section 5.2 and problem number 38. So an iron manufacturer produces chandeliers, railings, and latches. And each part has to be blacksmithed, assembled, and created for shipping. And then we're given some information. Each chandelier requires 3 hours to blacksmith, 5 to assemble, and 0.1 to create, and it gets a profit of $10. Each stair railing requires 10 hours to blacksmith, 8 hours to assemble, 0.6 hours to create, and the railings get a profit of $25. Lastly, the gate latch. Each gate latch requires 1 hour to blacksmith, 1 hour to assemble, and 0.1 hours to create, and the latch gives a profit of $3. And the manufacturer's some hours, some fixed hours, probably dependent upon labor and resources. 30,000 hours to blacksmith total, 40,000 hours total for assembling, and 120 hours total for creating. So we want to know how many units of each product should be manufactured to maximize profit. Okay, so the first thing I like to do is write down each variable. What are we looking for? X1 is the number of chandeliers manufactured. So this is what we're going to tell the iron manufacturer how many chandeliers should they make. We also want to know how many railings. So this is the number of stair railings to manufacture. Actually, that might be a better way to write this. So you're going to tell this manufacturer how many to make to maximize profit. And our last variable is x3 equals the number of gate latches. And I would suggest you kind of follow along just with a piece of paper and pencil and write this down. You don't have to worry about typing this up. So we've got the 3 variables. And now I'm going to set up a table. And just to try to stay organized, I don't know how many we need. I'll just go a little extra. And I want to think about what are some of the issues here. We need to think about hours blacksmith. We need to think about hours assembled and hours creating. And then we have the chandeliers. We have the railings, and we have the latches. So with information given, each chandelier, if we look at that second sentence, is 3 hours, so 3 times x1 to blacksmith. The chandelier also requires 5 hours to assemble. So I write 5x1. 5 times x1 will be the total number of hours for the chandeliers. And for creating, that's 0.1 x1. And if I fill this information out, the railings, let's see, that's going to be up here in the second sentence. Each railing is 10 hours to blacksmith, 8 to assemble, 0.6 to create. So that was 10 hours to blacksmith and 8 hours. Ooh, that should be x2. Excuse me, I made a mistake over here. These are all variable x2 for the number of railings. And then we have 0.6 x2. This would be the total number of the time for railings. 0.6 times x2 for creating. And then lastly, I want to go into the latches. That's the sentence right here. 1 hour to blacksmith, 1 to assemble, 0.1 to create. So technically that's 1x3, and this would also be 1x x3, and then lastly 0.1 x3. So now I'm going to write up, well, what are the constraints on all these? All the hours to blacksmith together can't be more than 30,000. So I'm going to type up 3x1, or write up, plus 10x2 plus x3 has to be less than or equal to 30,000. Let's see, I could make this look a little easier to read. Maybe not. Good chance I think I made too many columns here, but that's okay. Probably easier just to write this down on a piece of paper. So we've got the first constraint for the hours blacksmith. Now I need to add up all the hours assembled. 5x1 plus 8x2 plus x3. And that needs to be less than or equal to 40,000. And then lastly, hours creating, 0.1x1 plus 0.6 x2 plus 0.1 x3. This has to be less than or equal to 120 hours. So I don't actually need these. I could delete these columns just to give myself some more space on these. Alrighty. Okay, so we've got my constraints right here. And now we need to look at what are we trying to optimize. We're trying to maximize profit. So what's the profit on blacksmith? Or excuse me, the profit for chandeliers. That was $10. So I'm going to write 10x1. And then the profit's going to be $25 for each railing. And then lastly, it's $3 for each latch. So this is our profit function. So maybe I'll write a P equals out in front, because that's what we're going to maximize. So kind of rewriting all this, we want to maximize the profit. P equals 10x1 plus 25x2 plus 3x3, and subject to the constraints. To write all these in. And I'm just kind of summarizing what we already know. The constraint right here. And there's 1, 2, 3. The second constraint is for the hours assembled. And my third constraint, just copying and pasting back here, is for hours creating. And we also need to note that each of these variables has to be greater than or equal to 0, since we're dealing with actual physical objects. Okay, so that's setting up my linear programming problem given this scenario. And in the next video, I'm going to go through and show you how to solve this using Excel's solver.